This is the review and reflect before we talk about the topics in terms of determinants and inverses, which means we're going to be finding determinants, finding inverses, and using Cramer's rule to solve systems. So as a review, we want to make sure that we solve a system using matrix row manipulation, and this is our system. And we also need to be able to name it and state the solution set in curly brackets. You may have this already pre-printed, or you can write this down. You may want to pause the video here so you can both work on the review as well as to write down or reflect. After today's lecture, you should be able to describe when and why you cannot use Cramer's rule to solve systems of linear equations. Again, you might want to pause the video here to do that. Otherwise, I'm going to go on ahead and solve the review. So the first thing we need to remember for our review is that we're going to write it into matrix form. I'm going to have my coefficient matrix would be this, and then I'm going to augment the answer column, which is 2 and -1. So what we want to do when we're using row manipulation is we want to get the identity matrix on the left, and then we still have our answer columns, and we want to get numbers here. So the first thing I'm going to do is to make sure I get this guy right here to be a 1. So the first thing I'm going to do is multiply by 1/3 for that entire row. So when I do that, I'm going to have 1, -2/3, 2/3, and I'm going to have 6, 1, and a -1 here. After finding this one, I'm going to use it to create this 0 here. So I'm going to multiply by -6 to the top row and add it to the second row. When I do that, I'm going to create a matrix that will look like the top row not changing, and the bottom row, when I multiply these two numbers and add it to the bottom row, I'll get 0 here. I'm going to multiply -6 times -2/3. We can see that that simplifies to +4, and I add it to the 1, I get 5. Then I'm going to multiply -6 times +2/3, and again we can see that we're going to get -4, and we're going to get -4, and we're going to add it to this number here, so I'll get -5. Now that I've done that, then I'm going to get a 1 right here down the main column, main diagonal, sorry. So I'm going to multiply by 1/5. When I multiply by 1/5, the top row stays the same as 1, -2/3, and 2/3. The bottom row will become 0, 1, and -1. So now we're going to get this 0 here. I need to get a 0 here. So what I'm going to do is multiply by a +2/3 and add up. So this should be my last matrix. The bottom row stays the same. I'm going to multiply, I get 0, I add it to 1, I get 1. I multiplied, I get +2/3, I add it to a -2/3, I get 0. I multiply 2/3 times a -1, I get -2/3, I add it to a +2/3, I get 0. So I'm going to bring back my augmented matrix. I'm going to notice this is my identity matrix for a 2x2. And so this tells me that we have a solution set where x is going to equal to 0 and y is going to equal to -1. So in curly brackets, we have the point 0, -1. That's our solution set. This is a consistent and independent system. And that concludes this video.